All right, so AP problem 0003. We got a nice empirical formula and gas law kind of problem all tied into one here. So this first one, we have a compound containing C, H, and O. So this is like a C, X, H, Y, O, Z, N, B, I don't know, some other letter. Okay. And we have 1.2359 grams of this thing. Um, and then it gets burned in the presence of oxygen and gives us 2.241 grams of CO2. And the combustion analysis also shows that the sample contains 0.0648 grams of H. Oh, look, they already gave us a part. So we already know that H contains 0.0648 grams of H in this compound. Cool. Now, given the information they give us here, let's figure out, well, let's read the next question. Determine the mass in grams of carbon in the sample. Okay, so if I know the mass of carbon dioxide, I can relate. I know for every mole of carbon dioxide I have a mole of carbon. So let's get this in moles. We've got carbon dioxide, 1616, and 12 is going to give us 44 grams per mole. I'm undershooting a little bit on my decimals here. I probably should use more, but we're going to run with 44. Makes the number a little easier to deal with. So go to our calculator. 2.241 divided by 44 is 0.5093. So 0.5093. 0.05093 grams. I'm sorry, not grams. Get rid of that. Moles of CO2, which also means I have the same number. I have 0.5093 moles of carbon because they're related 1 to 1 here. I'll take my 0.05093 moles of carbon, knowing that they weigh 12 grams a piece. And we'll get, let's run back to that calculator for us here. Take that number times 12, 6112. 0.6112 grams of carbon. Awesome. So there we go. We've already answered the first part of this question here. So this is I. Okay, there's a decimal in there. Let's make sure we don't lose that. So let's move on to part B. When the compound is analyzed for N content only, the mass percent, let's catch that, of N is found to be 28.84%. Determine the mass in grams of N in the original 1.2359 gram sample. Well, so in this part, we'll do B down here. We know that if there's 280, this is 284% N. So once again, when we try to do percent problems, it's easy to assume out of 100. So let's say we have 28.84 grams per 100 grams of sample, grams of N per grams of this whole thing. I'm just going to call it sample since we don't really know what it is. Okay. Oh, well, I'm way overcomplicating this. This is 28.84%. If it's 28.8% N, and we know that the overall mass was 1.2359 grams, all I have to do is multiply this number by the percentage, 0.28884, and that'll give us the number of grams of N in the original sample. I was overthinking that one a lot. So 1.2359 times 0.2884 is 0.35, looking for 5 sig figs here. No, 4 sig figs, 0.3564. 0.3564 grams of N. Okay. Determine the mass in grams of oxygen in the original sample. Well, we know H, we know H, we know O, or we know N, we know C, so all we gotta do is subtract to find O. So part C here is just gonna be our 1.2359 gram sample minus the nitrogen part, grams of nitrogen minus the carbon part, which we got 0.6112 grams of C, minus the hydrogen part, which is 0.648 grams of H, and that's going to give me the grams of O here. So once again, bringing back our calculator. Everybody loves him. 359 minus 0.3564 minus 0.6112 minus 0.0648. We get 2.2035. 0.2035. Now, you'll notice that we carried all the way to this thousands place throughout this problem, and it's because we kept enough significant figures throughout the problem. If we had not done that, this number would be different, and we wouldn't be working on it right. Alright, so we've done 2, we've done 3. Oh, that's weird. Make sure we're boxing our answers, okay? Help the AP people find your answers. This is part 2. This is part 3. Part 2, part 3, and now we have to come back and we'll do part 4 here. Determine the empirical formula. Well, to do empirical formula, I'm going to need moles of all this stuff. What do we already have moles in? We already know moles of carbon. Good. So we've got 0.05093 moles of carbon. We do not know moles of N, O, or H for that matter. So let's start with H since it's way up here, 0.0648. We've got 0.0648 grams of H at 1.01 grams per mole of H. So we're going to take our number here, 0.0648 divided by 1.001. 0641 or 0642. 0.0642 moles of H. Okay. We've got 0.3564 grams of N. So we're doing 14.0 grams per mole of N, which is going to run us 0.3564 divided by 14, 0.0254, 4 sig figs, 0.025456, 0.025456 moles of N. Awesome. We got to get, and then we've got moles of C, H, N, we got O left. So our grams of O were 0.2035 grams of O. O comes in at 16 grams per mole. .2035 divided by 16 gives me 1272 moles of O. Now we got to pick out the smallest of the numbers out here. It's looking like the O is going to take the cake. So 0.01272 is what we're going to divide all of these guys by. To get our ratio. Well, I'll do the easy one. 1. Okay. 0.02456 divided by 1272 gives us 193. 642 divided by gives us 5.04, and then our last one up here, calculator's going to be in the way, of course, 05093 divided by 01272 gives us 4 even, 4.00. So we are looking at a grand empirical formula of C4, H5, N2O. That is a 4. Let's clear that up a little bit. A4. Awesome. And that will be our answer to part D. Or part 4. I say D, they say 4. Okay. Alright, so we got that. It looks like we have got A handled. Okay. Now, in B, a different compound which has that empirical formula. Okay, so now we're talking about something that is totally different. So we're doing a separate problem. We got to figure out its molar mass, knowing its density, its temperature, and its pressure. Okay, so here we go with another one of these gas law problems that we love so much. So in part B here, let's see if I can get a little more scroll. There we go. We're looking at, this is part B of the problem, we're looking at a PV equals nRT problem. We have pressure and we have temperature. But we do not have moles and we do not have volume. So what we're going to do is we are going to end up replacing those using our friend molar mass and density. Mass over volume. Rearrange, volume equals mass over density. N is going to equal molar mass times M. Yeah. Oh, I've got that upside down. I lied. Ignore that little piece, because this is actually M over N. So we're going to replace this, and this is actually going to end up equaling M over molar mass. So we'll plug these in, and we've actually seen this equation before, done this a couple of times. Remember, we are looking for molar mass. So in the game here, we are going to try to solve for MM after this stuff is plugged in. So we've got P times mass over density is equal to mass times molar mass times RT. I'm just going to switch these two things here, okay? I'm just going to switch them across. It's like doing a little cross multiply and divide, because you guys like to do that. So we've got PMMM equals DRT, and then so if I want molar mass by itself, molar mass is going to equal DRT over PM. Okay. Oh no, I forgot to plug in. What got left behind here? Oh, then I left mass behind. So when I divided by mass, it actually ended up canceling itself out, because there's another M here, M goes away, and we're left with molar mass equals density times RT over P. Okay. So molar mass equals, remember we're looking here, density. The density for this gas was 6.00 grams per liter. We've got, I'm going to go skip over to here to T. They already gave it to us in Kelvin, which is great. I'm going to divide out by pressure. Pressure was 0.983 atmospheres. So we're going to use our atmospheres R constant here. 0.08206 liter atmospheres per mole Kelvin. Before we waste our time putting anything into the calculator, we're going to check our units. Kelvins go away, atmospheres take off, liters are gone, and we're left with grams per mole, which is great because we're trying to find molar mass. So let's get this punched into our calculator here. You move back up. So we got 6 times 375 divided by 0.93883 times 0.08206 is going to give us a wonderful molar mass of, get this back in the right color, 187, 3 sig figs, 3, and more than enough, so 188. So molar mass is going to equal 188 grams per mole. Now, if you'll remember back, it said that the empirical formula, was, let's make sure we got this right, CH2Br. CH2Br. So we're looking at 12 plus 1 plus 1 plus whatever the mass of Br is. Why would I conveniently have a periodic table available to me while I'm doing these problems? That would make too much sense. 1 minute, you probably already looked it up. Br weighs 79.9. I'm just going to go ahead and round that to 80 because we're estimating here anyways. So that gives us 92.94 grams per mole 94 is going to go into our 188 twice, so we just need to double everything. So we would expect the molecular formula to be double that, so C2H4Br2, and that actually gives us our answer for both parts. We have molar mass, which is the answer to I, and we have the molecular formula, which is the answer to II. All right, so there's another one of our AP problems solved, and we're ready to go.